All right, so this is chapter 13. This is problem number one. And in this problem, it looks like they're going to have you calculate the sample mean of X bar, Y bar, and then they want you to do the standard deviation. These are the sample standard deviations that I believe you did back in chapter 3. And then they want the coefficient of correlation, or sometimes they just say the correlation coefficient, and then the coefficient of determination, which is just going to be that number squared. So again, you can open up the Excel file, you can plug all these numbers in. Notice they give you the X variables and the Y variables. And in a minute, I'm going to page down, I'm going to show you those calculations. But you should note that everything pretty much in here is review, because you've already done the correlation coefficient. But again, we'll go through it again. So you've got X bar, which again represents your sample mean, Y bar, again, sample mean, but you're just using the Y variables. Then you've got the sample standard deviation of X and Y and so forth. So let me move down to show you the calculations. And so what you'll need to do, again, is set up, I like to set these up vertically. And then, once you calculate your sample mean, you have an X minus X bar. There's your Y minus Y bar. And then, of course, you square each of these. Of course, you got to add them up. And then notice you divide by n minus 1, hit the square root button, and that's how you get your standard deviation. So this is a nice little practice exercise to review how to do that. And then, of course, the correlation coefficient. Note, this is your calculation on how to do that. So you go to this column right here for your correlation coefficient. Once you've added these numbers together, notice that's your numerator. And then you divide by n minus 1, which is 4. And then you multiply the standard deviations by each other. And then you're going to get a correlation coefficient of about 0.75. And then to get the coefficient of determination, you simply just square that. And so just for annotations, typically I would write out that, again, the correlation coefficient is said to be R. So if R is equal to 0.75, the coefficient of determination is sometimes referred to as R squared. And of course, you just square it, and then that's where they got the 0.5625. All right, so that is my comments on problem 1. I think you can fill out the rest of that. All right, so on problem 2, on this one, it's pretty much the same thing, except they're going to want you to fill in some of these boxes. But you notice the headings, you got X and Y. They put it horizontal here, but it's probably better to put it vertically. So you got your X differences and your Y differences, and then you square them. And then, of course, you multiply the differences. And then notice you have to add them up. And depending on your rounding, they give you a plus or minus margin of error in that. So then, of course, you can get your sample mean of X bar. You can get your sample mean of Y bar. And then, of course, notice they want you to do your sample standard deviations as well. Get your correlation coefficient once again. And then, of course, square that to get your coefficient of determination. And I think that's pretty much it. Pretty redundant. It's pretty much the same thing as your last one. There's just a lot of calculations you got to do. But it's good practice. Again, some of the stuff is review. But you'll need this in a moment in the next couple of problems when we get to the regression. Okay, so that is my comments for problem 2. Let's check out problem 3. And on this one, again, you can open up the Excel file if you want. If I open it up, notice you've got number of airings and Saturday, Sunday sales in dollars. And when you open this up, of course, I'll label this on the screen for you as you're practicing it. But I would label the first column as X, and then label this one as Y. Okay. And so again, sales is going to be the dependent variable. And then, of course, I'm going to move down below. They want you to do a scatter graph. So using your plots here, you can plot it out like that. And then, of course, they're going to want you to do, again, the same calculations as before, the correlation, coefficient of correlation. And then here's going to be all your calculations again. Notice the setup, X, Y. You take the differences, you square them, add them up, divide by 4 to get your standard deviations. Here's your differences multiplied by each other. You'll need that for your correlation coefficient. And again, a 0.93 means that that's a strong relationship. All righty, and I think that is good for my comments on problem 3. Problem 4 is going to be very similar. And so again, usually the way they set these up, they typically give you the X variable in the first column, and then here's going to be your Y. So that this will be, the y variable will be your dependent variable. And again, as you move down, here's your scatter graph. And then again, same thing. Again, you got to plug it into your table here. You got to fill in some of these pieces. Should be pretty easy for you. X bar, Y bar, standard deviations, correlation coefficient. And there you go. All right. So again, first 3 or 4 problems are pretty much very similar. You're just practicing. And then the last one, we will do some more of these calculations. So again, here we go again. Notice we've got, let me plug that in. So you got police and then number of crimes. So X and Y variables is how I would label that. And then of course, you know, this is going to be a negative relationship, it looks like. And then once again, right here, you got your X bar, Y bar, standard deviation of X and Y, again, correlation coefficient, coefficient of determination, and so forth. And hopefully you plug those numbers in. And then down below here is going to be your explanation on how to get those. Strong inverse negative relationship. All righty, guys. So that's my comments on your chapter 13 homework.